Hello everyone, my name is Denis Antipov, and this is a video presentation of our joint work with Maxim Puzdalov and Benjamin Doer about the runtime analysis when we start in a good solution. There are three main runtime analysis approaches, which are the total runtime analysis, fixed target analysis, and fixed budget analysis. Let me illustrate them. For this, consider this plot of a run of some algorithm on some function, where on x-axis we have the time and on y-axis we have the fitness obtained by the algorithm by this time. To find the total runtime, we find the best fitness and see what time the algorithm needs to find this best fitness. The fixed target approach is a more general approach where we consider some certain fitness value and try to find how much time the algorithm needs to reach at least this fitness value. And then there is a mirrored approach, which is called fixed budget, where we have some time and we try to find what will be the fitness after this number of iterations. And we propose to a new approach, which we called the fixed start approach. And here we fix some certain fitness value and try to see how much time algorithm needs to find the optimum starting from this certain fitness value. And we see several use cases for this approach. First of all, in some cases we can just build a good solution by studying the problem structure or by some common sense. And it is interesting how much does it benefit us and how faster the algorithm will be from this good solution. The second case is in the dynamic environments, when the environment changes a little bit and we had found an optimum. Then we aim at finding the new optimum as fast as possible, and for this we need to know which algorithm can do it in the best way. And third, when we choose different algorithm for the optimization dynamically, and we want to choose the best algorithm at each stage of the optimization, then the fixed start results can give us some hints on which algorithms are most beneficial to choose at this stage. And also we must know that in some sense this fixed start approach complements the fixed target approach to the total runtime approach. Okay, and we made some first steps towards this kind of analysis on 1max function, and we observed that different algorithms benefit differently from a good solution. And for example, the 1 plus 1a meets the cap and collector effect, while the 1 plus lambda comma lambda j doesn't. More precisely, let d be some initial distance from the optimum, and then the runtime of the 1 plus 1a is n log d, while the runtime of different modifications of the 1 plus lambda comma lambda j is big O of square root of nd, or slightly greater for some of the modifications. To understand the difference between these runtimes, consider d equals to square root of n, and in this case the 1 plus 1a still has n log n runtime, which is asymptotically the same as if we started from a random solution. But the 1 plus lambda comma lambda j has a sublinear runtime. We complement our theory with some experiments. In first bunch of experiments we consider how the algorithms perform when they start in square root of n from optimum for different problem sizes. And here we see that the best results are shown by the self-adjusting lambda, where we adjust lambda with the one peep through. But we also see a good performance of the 1 plus lambda comma lambda j with heavy-tailed parameter choices. Then we also considered how different algorithms perform starting from different distances with a fixed initial distance. And here we see that the heavy-tailed choices show even better performance in small distances, but still we must admit that the one-piece rule shows the best results. To sum up, we proposed a new fixed start approach to the runtime analysis, and even the first walk in this direction showed that it is important to choose an algorithm wisely when we can benefit from the good solution. And we showed that the 1 plus lambda cum lambda j should be preferred over the 1 plus 1a. And we are optimistic that there are still a lot of insights we can get from this fixed start approach. Thank you.